Okay, so I'm going to try to quickly walk through these two problems. And I already have them written out, but I felt I should probably explain some of this stuff. So, first question here, we have a picture that measures 10 by 5 centimeters to be surrounded by a mat of uniform width. So that means like you have a picture and the border is all the same around that picture. So a mat, they that's what they call kind of like the border in pictures. You might have like that white outline around a picture in a frame. So the border is going to be the same width all the way around. The area of the mat is to be twice the area of the picture. What is the width of the mat? And so I kind of drew out a little diagram here. If we say that X is the width of the mat, so like that the thickness of the border, we could draw something that looks like this. So you have your picture, 10 centimeters by 5 centimeters in the inside, and then there's like that, maybe that like white border around, and that is going to have a width of X, or like over here really has like a height, but that thickness of that border is X. So we could think of, if we had the photo with the mat combined, then it's the 10 centimeters of the photo plus the X plus the X on both sides. So that whole side's like 10 plus 2X. And then the height, we have the 5 centimeter height plus the X at the top and the X at the bottom. So this is like 5 with plus 2 X's. So let me cover some of this up so I don't go too quickly here. So the area of the mat, we're told, has to be twice the area of the picture. Got a little celeb sighting here. And so the area of the mat, well, if I want just the area of the border, not like the picture in the inside, well, then I can do the area of the whole thing. So the width was 10 plus 2 of those X's, and the height was 5 plus 2 of those X's. And I can subtract out, I can cancel out that area of the picture. So 10 centimeters by 5 centimeters, that's the width times the length. And all of that area of the mat, so the area that's left over after taking out the picture, should be equal to 2 times the area of the picture. We can expand things out. So I can use FOIL here. 10 times 5 is 50. 10 times 2x is 20x. 2x times 5 is 10x. 2x times 2x is 4x squared. Minus 10 times 5, so minus 50. And all of that equals 100. Sorry for the camera going in and out here. Collect the like terms, so 4x squared. We got 30x's here. I got 50. Minus 50 is 0. Bring the 100 over, we get negative 100. And we can try to factor that. A common factor of 2. Here you could try to go directly, or you could use that decomposition method we have, but this does factor, and it eventually, no matter which method you choose, if you do the decomposition, it'll be a couple more steps, but you should be able to get it down to this here. And we could double check. Yeah, that's our 2x squared, negative 5x, and 20x. That gives us 15x, and 10 and negative 5 gives us negative 50. Perfect. See when our factors are equal to 0. So x could be equal to negative 10. Or 2x minus 5 equals 0 when 2x equals 5, or when x is equal to 5 over 2. Having a negative width up here doesn't really make any sense. So negative 10 is going to be inadmissible, which means that's the only answer that makes sense to answer our question of what is the width of the mat. And so the width of the mat must be 2.5 centimeters wide. I'm going to see if I can pull out here and get the whole thing at once. But that solves that problem there. The second problem, similar idea, although we don't have the add-on in both directions, or sorry, I guess on both sides in each direction. It's just on one side in each direction. We have a rectangular garden. 6 meters long by 3 meters wide, and it is doubled in area if we extend out each dimension by the same amount. So you can draw something that looks kind of like this. You have your original garden, 6 by 3, and we could add the same amount in both directions. We could call that x, which let x be the amount each dimension is extended, and that gives us something that looks like this. And if we turn that into a formula where we know, well, the new garden, that new extended garden should be twice as big as the original garden. And that new extended garden, that looks like 6 plus x and 3 plus x. So that's our length and our width. And that's 2 times the area of the original garden. So 6 times 3 times 2 because we're doubling it. And if we start to simplify things, expand out this side, multiply all this together, move everything to one side and collect your like terms, and we get something that doesn't factor this time. So if we're solving an equation we can't factor, we'll look to use quadratic formula. And it eventually gets down to -9 plus or minus root 153 divided by 2. And so if we split that into our 2 different cases here, we end up getting our positive square root answer is 1.7 meters, and the part with the negative square root gives us negative 10.7 meters, which again, that doesn't make sense for this problem. I can't have a negative width here, so that would be inadmissible, works mathematically, doesn't make sense for our problem. And so then only the one answer makes sense. So each dimension should be extended by 1.7 meters because we had to round to, oh, there we go, 1 decimal place. So if I pull back out on this one, there's our full solution there.